Good morning, students. Today we are going to learn about digital comparator. This is the circuit for single bit digital comparator. Okay. Comparator is used to compare two values. Okay. So first we will see about the working of single bit comparator. Single bit comparator compares two single bit values. Okay. In this, A and B are inputs. In comparator, there are three possible outputs. One is A is equal to B, another one is A is less than B, and the last one is A is greater than B. Okay. When you compare two values, we will have three possible outputs. Okay. A is a single bit value, B is a single bit value. So A can be either 0 or 1, B can be either 0 or 1. So there are four possible combinations. Okay, 0 0 0 1 1 0 1 1. Okay. In the first case, A is equal to 0, B is equal to 0. Okay. Actually, Y2 will be 1 when A is equal to B. Okay. Y1 will be 1 when A is less than B. Y3 will be 1 when A is greater than B. Okay. Now A is equal to 0, B is equal to 0. Both are same. So Y2 will be 1. Okay. 1 is assigned to Y2. A is equal to B. Okay. Next case, A is equal to 0, B is equal to 1. That means A is less than B. So Y1 is equal to 1. Okay. A is less than B, so Y1 is equal to 1. In the next case, A is 1, B is equal to 0. So A is greater than B. So Y3 will be 1. Next case, A is equal to 1, B is equal to 1. Both are equal to 1. So A is equal to B. Y2 will be 1. Okay. In the first row, A and B both are equal. In the last row also both are equal. So Y2 is equal to 1. In the second row, A is less than B. So Y1 is equal to 1. In the third row, A is greater than B, so Y3 is equal to 1. So 1 bit digital comparator compares two single bit values. Okay. Next, this is the circuit for 4 bit comparator. Okay. So comparator is used to compare two datas. Okay. Here we are comparing two 4 bits data. Okay. A is the data. A is one of the data. B is another data. Okay. So A3 to A0 is the data A. B3 to B0 is the data B. Okay. Here also, if A is equal to B, then Y2, sorry, Y3. If A is equal to B, then Y2 will be 1. If A is less than b, then y1 will be 1. If a is greater than b, then y3 will be 1. Okay. Now we have two 4 bits data. Okay, A3 to A0, B3 to B0. When A3 is equal to B3 and A2 is equal to B2 and A1 is equal to B1 and A0 is equal to B0, then A is equal to B. Okay, if all the bits are same, that means A3 is equal to B3. First MSB bit of A and B both are equal, and second bit of A and B are equal, that is A2 is equal to B2, and the next bit A1 is equal to B1, and then LSB bit of A and B both are equal, then A is equal to B. Okay, so we can write it as Y2 is equal to A3 XNOR, not XOR. If both are equal, then the output will be 1 in XNOR gate. So A3 XNOR B3 and A2 XNOR B2 and A1 XNOR B1 and A0 XNOR B0, then Y2 is equal to 1. Okay, if A3 is equal to B3, why I am using XNOR? In XNOR gate, the output will be 1 when both inputs are 1. So here A3 is equal to B3. So A3 XNOR B3, and so dot A2 is equal to B2. So A2 XNOR B2, and so here dot A1 is equal to B1. So A1 XNOR B1, and so here dot A0 is equal to B0. So A0 XNOR B0, then Y2 is equal to 1. Okay, I am taking X3 is equal to A3 XNOR B3, X2 is equal to A2 XNOR B2, X1 is equal to A1 XNOR B1, X0 is equal to A0 XNOR B0. So X3 into X2 into X1 into X0. So Y3 is equal to X3 dot X2 dot X1 dot X0 dot. Okay, next we are going to derive the equation for A is greater than B. Okay, A is greater than B will be 1 when A3 is greater than B3, or A3 is equal to B3 and A2 is greater than B2, or A3 is equal to B3 and A2 is equal to B2 and A1 is greater than B1, or first 3 bits are equal. A3 is equal to B3 and A2 is equal to B2 and A1 is equal to B1 and A0 is greater than B0, then A is greater than B, that is Y3 will be 1. Okay, can you understand? When A is greater than B, if A3 is greater than B3, or suppose first bit, that is A3 is equal to B3, then you have to check the next bit. So A3 is equal to B3, and if A2 is greater than B2, then we can say that A is greater than B. Or if first bit A3 is equal to B3, then the second bit also same, A2 is equal to B2. In this case, you have to check the next bit, whether A1 is greater than B1. If A3 is equal to B3 and A2 is equal to B2 and A1 is greater than B1, we can say that A is greater than B. Or if all the first three bits are equal, fourth bit A0 is greater than B0, then we can say that A is greater than B. That means A3 is equal to B3 and A2 is equal to B2 and A1 is equal to B1 and A0 is greater than B0. Okay. Once again I am explaining. If all the bits are equal, then we can say that A is equal to B. Okay. Now we are going to check whether A is greater than B. Okay. For that, first we are checking the first bit. If A3 is greater than B3, then you don't need to check the other bits. You can say that A is greater than B. Okay. If A3 is equal to B3, first bit is same, then you have to check the next bit. Okay. Whether A2 is greater than B2. If A3 is equal to B3 and A2 is greater than B2, then we can say that A is greater than B. Or if A3 is equal to B3, first two bits are same. That means A3 is equal to B3 and A2 is equal to B2. Then you have to check the third bit. A1 is greater than B1. If A3 is equal to B3 and A2 is equal to B2 and A1 is greater than B1, then you can say that A is greater than B. Okay. Or if all the first three bits are equal, then you have to check the fourth bit. If fourth bit A0 is greater than B0, then we can say that A is greater than B. That means A3 is equal to B3 and A2 is equal to B2 and A1 is equal to B1 and A0 is greater than B0, then A is greater than B. So Y3 will be 1. Okay. We can write it as Y3 is equal to, here A3 greater than B3. That means A3 is equal to 1, B3 is equal to 0. So we can write it as A3 B3 dash. Okay. Then we have OR. So plus. Next A3 is equal to B3. I am taking A3 is equal to B3 as X3. Okay. So here X3 dot, next and, so dot, A2 is greater than B2. So A2 B2 bar. Next we have OR. So plus. Next A3 is equal to B3 and A2 is equal to B2. So A3 is equal to B3 means we can write it as X3. A2 is equal to B2 means X2. Okay. So or X3 dot X2 dot. Next we have A1 is greater than B1. That means A1 is 1, B1 is 0. So 1 0. So A1 B1 bar. A1 B1 bar. Next we have OR. So plus. Next A3 is equal to B3. So X3. A2 is equal to B2. So X2. Next A1 is equal to B1. So X1. Next A0 is greater than B0. That means A0 is 1, B0 is 0. So A0 B0 bar. Okay. Next we are going to derive A is less than B. Okay. Just opposite to the A is greater than B. Okay. Just greater than symbol replaced by less than. Okay. Okay. Here first we have to check first bit, MSB bit. Okay. If A3 is less than B3, simply we can say that A is less than B. If suppose both are equal, that is A3 is equal to B3, then you have to check the next bit. So A3 is equal to B3, and if A2 is less than B2, then you can say that A is less than B. Or if both two bits are equal, first two bits are equal, that means A3 is equal to B3, A2 is equal to B2, then you have to check the next bit A1, whether A1 is less than B1. If A1 is less than B1, then we can say that A is less than B. Or in the case of first three bits are equal, that means A3 is equal to B3, A2 is equal to B2, and A1 is equal to B1, then you have to check the next bit, last bit, LSB bit, okay, whether A0 is less than B0. If A0 is less than B0, then you can say that A is less than B. Okay, first case it may be A3 is less than B3, or if both are same, A3 is equal to B3, then you have to check A2 and B2. If A2 is less than B2, then A is less than B. If it is not satisfied, then suppose we have A3 is equal to B3 and A2 is equal to B2, then you have to check A1 and B1, whether A1 is less than B1. If A1 is less than B1, you can say that A is less than B. In the last case, we are checking last bit. Okay, the first three bits are equal. A3 is equal to B3 and A2 is equal to B2 and A1 is equal to B1. Then you have to check A0 and B0, whether A0 is less than B0. If A0 is less than B0, then A is less than B. Okay, so you can write it as Y one. Okay, Y1 is equal to, here A3 less than B3, so A3 is 0, B3 is 1, 0, 1. So A3 bar B3 plus A3 is equal to B3. So here I am using X3. So X3 next, and so dot A2 less than B2. So A2 is 0, B2 1. So A2 bar B2. Then we have OR. So here plus you have to use. Then A3 is equal to B3 and A2 is equal to B2. So X3 dot X2. And so dot next A1 less than B1. That means A1 is 0, B1 is equal to 1. 0, 1. So A1 bar B1 plus, here we have OR. So plus next A3 is equal to B3. So X3, A2 is equal to B2, X2, A1 is equal to B1 and A0 is less than B0. So A0 is 0, B0 is 1. So 0, 1. So A0 bar B0. Okay. You see here A is equal to B. That is Y2 will be 1 when X3 is equal to 1, X2 is equal to 1, X1 is equal to 1, X0 is equal to 1. The product of X3, X2, X1 and X0. So you see the diagram here. Okay, this is Y2. Okay, product of X3, X2, X1, X0. X3 is A3, X0 B3, A2, X2 is A2, X0 B2, X1 is A1, X0 B1, X0 is A0, X0 B0. The product of X3, X2, X1, X0 gives the Y2. Okay, so this is Y2. or A is greater than B, Y3 is equal to A3 B3 bar. Please note it here. Y3 is equal to A3 B3 bar plus X3 A2 B2 bar plus X3 X2 A1 B1 bar plus X3 X2 X1 A0 B0 bar. Okay, A is greater than B. Here A is greater than B. So A B bar, A3 B3 bar. In this we are connecting A3. Okay. Next B3 bar. Okay, A3 B3 bar. Next here first input is X3, then A2 B2 bar. Next X3 X2 A1 B1 bar. Here X3 X2 X1 A1 B1 bar. Okay, so it gives Y3. Here just opposite, Y1 A is less than B, so A3 bar B3. Okay, here A3 bar is connected to this AND gate, B3 is connected to this AND gate. Okay, next X3 A2 bar B2. Next X3 X2 A1 B1 bar. Here X3 is connected, X2 is connected, X1 is connected, then A0 bar B0. Okay, so it gives Y1. A is less than B. So this is the circuit for 4-bit comparator. Here we are comparing 2 4 bits data. Okay. Okay, thank you.